So today we're still talking about functions, but we're going to focus on how to take functions given in three different formats: as a table, as a graph, as an equation, and kind of find their match. So in other words, if I give you a table, we're going to talk about how you can take that table of x, y values and match it to a graph. Then we'll talk about matching a graph to a number of tables, and then lastly talk about matching a graph to an equation. So our process for this, really there's just one real step, and that is to list the ordered pairs. So go ahead and write that. Number one, list the ordered pairs. Now what in the world am I talking about? Where do you get these ordered pairs that I'm asking you to list? Where do you get these ordered pairs? From the graph and from the table. So this time we're given a table of values and they want us to match it to a graph. So I'm just going to take this table of values. Here are our x coordinates and our y coordinates. Remember, each ordered pair is made up of an x and a y. And I'm just going to list these three ordered pairs. Here's one. Here's a second ordered pair. Here's that third ordered pair. I'm just going to list them. So first we have -3, 4. And then we have 0, 2. And then we have 3, 0. And then I'm just going to plot the points to find my match. And we're going to work smart, not hard. So I'm going to start with -3, 4, and if it doesn't fall on this graph, then I'm moving on to the next one. So I'm just going to take 1 point, and if I can eliminate any of these graphs, that's exactly what I'm going to do. So we will start with -3, 4. And remember, our x value tells us how far left or right. Since it's negative, we're moving to the left. So I'm going to move to the left, -1, -2. Here's -3. But this says it needs to be -3, 4, and that's up here somewhere. And that does not fall on my line. So what do I know about this graph? It's not a match. So I'm going to put a big X over it. Is that? It's not. Well, it is I like you using that vocabulary. Fantastic. It is a function because each X has exactly one Y value, but it's not the function for this table. So you're kind of right, and that is not the function. Okay, let's move on to this one. I'm going to again start by trying to plot this point. -3 up 4 is about here, and no go. That point is not on this graph. Therefore, this is not a match. Now, through process of elimination, I know it's probably going to be this last one, but we're not going to just use process of elimination. We're actually going to do it. Make sure these points fall in it. So we'll start with -3, 4. So far, so good. And then yeah, awesome. We've got 0, 2, and I already heard someone say it works. We're good. And then we've got 3, 0. All the points fall on the line. Put a big star. That's our match. Now, I like how folks are testing every single point. Let's say we had a fourth graph that 1 point fell on it, but the other 2 did not. Then that graph wouldn't work as well. They all have to fall on that line. So in order to find a graph for a given table, you're going to list the ordered pairs, then plot the points to find the match.